It's Don here from the board. Thanks for coming along and checking out this video. So today is going to be kind of an introduction to my next project, which I'm going to just do a packaging opening, kind of an unboxing thing, and I want to talk about where I'm going with this equipment. I don't really know what the time frame is going to be like, but this is probably going to be the first of a couple of videos on making a home-built force tester, a switch force curve tester. So in context, if you're new to this mechanical keyboard space, a lot of the actual switches out there that you can get will have these things called force curves, and the force curves are used by people in the community to understand what a switch might feel like, and it's typically plotted along the two axes, which one is going to be the travel of the actual stem as the switch is being depressed, and then the other axis is the actual force that is being represented within the switch, and the curves will show off either how smooth and straight or how fast the ramp up is of a linear switch. It might show the tactile bump of the tactile switch, it might show the reset point as the stems come back, and all sorts of different things, and they can be compared relative, and it will tell you and show you different things about the shape of the stem and force of the springs and all that kind of stuff. Now there are a couple of different setups out there already for it, but typically they tend to be relatively expensive, so not a lot of people have access to necessarily that much money or the equipment behind some of these force curve setups. So me talking to people on the Australian Mechanical Keyboard Discord got kind of egged on to maybe trying to give it a crack, and that's what I have an idea in mind that I want to do. Now, in order to realistically measure a force curve, you need something that's going to measure force, right? The amount of weight or pressure that is being felt by a sensor that's being exerted by the switch stem when you move in a consistent distance, right, in a linear fashion. So you need to start off with something that's going to detect that movement and the force. So today's video is really just unpackaging and having a look at a really basic load cell that I've purchased. Now this video is not at all sponsored by anybody. I bought this with my own money, so I'm just going to show you what I bought. Now I have some credit with Banggood because of all the other videos that are related and whatnot, and so I went and found one of the cheapest load cells that they have available, which is this thing. So for $5.50 US and free shipping to Australia, you can get a 1 kilogram load cell, and it even comes with the actual module that will convert the signal, the resistance of the voltage as the cell moves. So probably this is the best side view to look at it, but it will tell you that there's a direction that the force should move. There is meant to be a sensor that's attached to the actual metal here, and then it goes through these wires, and those wires will go to the actual PCB here, the module, which then you would hook up to something that would read and record the voltage amounts, and you would calibrate those voltage amounts to indicate the amount of force at that particular data point in time. Now, how does a load cell work? So just some really basic info is available on the wiki page for load cells, but effectively what it is it's a sheet or a small sensor, and they've got it kind of represented here, that is attached to the bar of metal, and as the bar of metal flexes, as it moves either in a compression or in a torsion, it actually causes this sensor to flex, and the flexing of that changes the electrical resistance within that sensing piece of material, and that's the voltage that will change relative to that resistance change. So that's what we're hoping to see. Now, it was $5.50. Honestly, like, if it has everything in there, that's 100% win. Okay, and the listing is quite positive about it, because what you get is just these three pieces. You're going to need screws, you're going to need other things like that to make this work, plus of course another chip, another card, another daughter board, like an Arduino. I'll probably use a Pro Micro because I still have some of those, and you would just program it to read and output. Now people are hooking them up directly to displays, and you can see that, you know, it doesn't look super duper complex, but people are saying that it works, and it works well. So that's what I'm looking forward to. That's what I'm hoping to see. I will need to reach out to other people to help me with some code to tell me how do I actually get this thing to work and the values to come out of it, but we'll get to that probably at a later date, plus how I will integrate it into holding a switch and the force being applied to the switch. So if we head on down to the desktop, don't have a tray, but there it is, a very standard packaging, no protection whatsoever. It's just straight up in a sealed baggie. I've taken obviously the address label off, so I'm just going to make sure that there's no wires in this section that I'm about to snip, because that would be really tragic if there was. And there you go. So not really the most well protected out there. Now I chose the lightest sensor. This is a 1 kilo bar, because 1 kilo is in excessive of what our mechanical keyboard switches are going to experience. So it should have no problems whatsoever in being able to detect that. If anything, I don't know what the resolution is like for a 1 kilo bar, if it'll even detect the fine amounts of change that is required. It might be not sufficiently fine enough. Okay, so there's the actual sensor, and then in a little bit of electrostatic plastic in the little baggie here, we do have the module, and we got some header pins in there. So it's pretty much as described. I don't really have too much issue, although you can see the shipping, you know, there is some sort of blemish on that indicating there was a bit of force on this. It probably did roll over in something and, you know, mark up the plastic from that. Hopefully none of these little resistors and capacitors or the actual integrated chip here has been damaged in the process. So what we've got here is the load cell. So there is the sticker for the direction of force. So I would assume that when you hook it up, the force should be in the direction of the arrow pushing down, and that we've got a series of the actual strain gauges. So there's one that's glued onto here and another one that's glued onto here, and then the wires come relative to that to the actual module. So it's fairly straightforward. You know, this pushing down will cause these top ones to stretch and these bottom ones to flex, and then somehow in regards to the difference between those two, the voltage will change and therefore give you a reading. So that is it. Fairly straightforward. It's really important to make sure that you actually maintain the correct direction from what I've read, because if you have this inverted, the values that you're going to get are obviously going to be wrong. You could probably invert that, but you know, shouldn't be too hard as long as you just remember what the right direction is, and the sticker is pretty handy for that. So for $5, $5.50 US, and you know, a couple of weeks of waiting, that is what you're going to get. Fairly straightforward, fairly simple. I'll need to figure out a way to mount it on a base. I'm going to need a way to mount a switch on top, and I'm going to need a way to actually press down in a consistent linear fashion that will allow this to sense what is happening within the switch. Whether it's going to be on top of the switch, whether the switch will be on top of it, is yet to be determined. Maybe I'll try both setup and see what actually comes out and makes sense. I'll probably try it with a switch that there is a known force curve out there as well, just to make sure that it correlates and, you know, collaborates corroborates, I don't know, whatever the right English is for that, that will actually show that my setup is working as intended. So there you go, nice and straightforward, very simple. cheap, affordable, and I guess if this kind of goes according to plan, then it might allow you guys out there to try making your own force curve devices, and then give people more options to test how well their switches are wearing, or maybe whatever modifications that they're doing to their switches, lubing, or if they're, I don't know, putting stems into tumblers and polishing them, and all sorts of other crazy wacky things. Well, that's it. Thank you very much for coming along and checking out this video and listening to me ramble about my ideas for a homemade switch tester. Hopefully we'll see more future videos, in relation to how this project is going and how it all pans out. Hit that subscribe, like, bell button, as you all know, and of course, until next time,
Happy clacking.
happy clacking.